Hi there, welcome to Math with Bill. I'm Bill and this is Math. Today's video, we are looking at what I like to call the jailbreak method for simplifying radical expressions. Okay, so let's do a quick review on what radical expressions are. Radical expressions are anything that have our radical sign here. Radical sign looks like division, but it's got that lip out front. We have three big pieces. There's the index, and that is the number, whatever it might be. We're going to call it the number n. So that's our index. That's telling us what type of root we're looking for. And then we have the radical sign itself, and we have the radicand, which is that thing which is underneath or inside of our radical sign. Now, with the jailbreak method, I like to tell a little bit of a story here. Okay, so we've got three different characters in this story. Our index will be played by the role of the guards. Okay, the radical sign is known as prison. And the radicand are the inmates. Okay, and so there are different levels of prisons, right? There's minimum security prison, there's maximum security prison, and there are things in between. Now, the level of prison is designated by our index, by the number of guards that they have there at the prison. There's an interesting thing about the guards, though. With every group of guards, there is always one spotter and n-1 snipers. So of those guards, all of them except for one will have guns. And the other one that's left over is the person who is looking for maybe anybody who's trying to break free. Okay, our radical sign is the prison. Okay, so our inmates are in the prison and they're hanging out. In prison, there are gangs that tend to show up. And these gangs, or just groups of individuals, they like to associate together. And so, really, when we're doing this, we need a thing called the prime factorization. So we should break all of our big numbers down into just prime numbers and the product of those primes. And so, let's take an example look here. You see, let's take an example look at maybe the cube roots of 405 x to the 4th y squared. Okay, so really what we have are a couple of different groups here in this third degree prison. So maybe it's somewhere in the middle, not a maximum security or whatnot. But so we've got three guards, which means that there's one spotter and two snipers, right? Because the 1 plus 2 makes 3. 405 here is a group of numbers, and 405 isn't a prime number. I can break that down. So I'm going to take and break down 405 into, well, it ends in a 5 or a 0, so it's divisible by 5. And it's 5 times 81. 81 can be broken down into 9 times 9, or really 3 squared times 3 squared. If I were to rewrite all of this as its prime factorization, I would have cube roots of 5 to the first times 3 squared times 3 squared is 3 to the 4th, x to the 4th, y squared. Now, here we are in a prison with 3 guards. We've got 5s, 3s, x's, and y's. Here's the jailbreak portion of this. Once we get to this piece, any group of inmates, any term, be it a number or a variable that has more than the number of guards, that has a larger exponent than the index, like both 3 and x do, because it's 3 to the 4th and x to the 4th, since those are more than 3, they're going to make a jailbreak. Okay? And they jailbreak in the same group as the number of guards. So if there are 3 guards, that means you need at least 3 members to make a jailbreak, and only 3 of those members will go. So we're going to have 3 cubed try to make a jailbreak. They jump over the wall and they're running, they're running, they're running. The spotter spots the 3 men and says, so there's a 3 and a 3 and a 3. He spots the first of those 3s. He goes, fire! And the first sniper shoots and kills him. And then he says, fire! And the second sniper takes and shoots him. But now the snipers are out of ammo. And the third 3 escapes to outside of the prison wall. The same thing would happen for an X. But again, only 3 of those X's are going to go. 2 of them will be shot or killed, and 1 will get away. Afterwards, we end up with a 3 and an X outside the wall, and then the cube roots of 5, which is left inside, and a 3, which is left inside, because we had 4, but we used just 1 of them. We're left with an X inside, and Y never got to participate, didn't lose anyone, and so they still have Y squared inside. So, quick recap. For the jailbreak method of simplifying, first thing we want to do is take our radicand and do a prime factorization. Make sure that all of our numbers are broken down so that they are only a product of primes. And then for every term where the exponent is at least the index, or there's as many members of a group as there are guards, that means that a jailbreak will happen. Continue this until all of the exponent values are less than the index, and you will have simplified your radical expression.